Alright, so I think I'm recording. I can never tell for sure. Let's take a look at this. Well, oh boy, which one is this? This is Skill 3E. Skill 3E Day 3. I think this was the first day that we were doing the function compositions. Alright, so it wants to find the equation for f composed with g, and then also to find its domain. So f composed with g takes the function g and plugs it into the function f. The function g is simply x minus 1. Now, what the function f does to input, it always does, and this is the input, it always squares the input. It squares the input and then adds 1. That's what f always does. Whatever's inside the parenthesis, whether it's a number or an expression or a really ugly, complicated expression, it's going to square it and add 1. So we need to square x minus 1. Now be careful here. Exponents don't distribute. This is not x squared minus 1 squared. Remember that this means x minus 1 times x minus 1. So, however you prefer to multiply binomials, whether they've taught you a table or some phrase FOIL or whatever, the mathematical property is the distributive property. And if you apply that distributive property, multiplication distributes over subtraction. So I have x squared minus 2x plus 1 and then plus another 1. I'm just going to go ahead and write my plus 2. So this is the expression they wanted for this new function f composed with g. So this is my first answer. Now, it wants me to find the domain for this, and you have to be careful. I can do this a couple different ways. I can look at this and say, well, the domain is all real numbers, but then I also have to make sure that I include any restrictions that were on g. What makes this problem easy is the domain of f and the domain of g are both all real numbers. We don't have any variables in a denominator. We don't have any variables underneath a square root. So I like to describe this function composition like an assembly line. That first you have a number from your domain that is going into this function g. What comes out of g, we use the expression g of x. So where x is the input, this is an x coordinate, this output g of x is a y coordinate. This is input and output. Then this g of x becomes the input for f. And out of f, well, if this g of x is the input is always in between the parentheses. That's where we get this notation, f of g of x. Now, two things have to be true to be in the domain of this function composition. First, x has to be in the domain of g. This is the symbol for an element of. It means a member of. X is a member of the domain of g. Now at the same time, the output of g, this y coordinate, this g of x, has to be a member of the domain of f because it's the input into f. Well, since the domain of g was all real numbers, x can be anything to go into the function, and who cares what comes out of it, if it's all positive numbers or if it's sometimes positive or negative or 0. F of x has domain of all real numbers as well. Both the domain of g and the domain of f are all real numbers. So there's no restrictions for the input into g. There's no restrictions for the input into f. Therefore, we can plug in anything we'd like, and the domain of this function composition is all real numbers. Alright, so let's take a look at part B. It's asking us to find the function composition, the expression for it, and then again the domain. This time, however, they've changed the order. Now, Some things are what they call commutative, like addition. 3 plus 2 is the same thing as 2 plus 3. But the order for this function composition is not commutative. I'm not expecting the same answer. Over here I had x squared minus 2x plus 2. I'm expecting a different answer when I plug f of x into the function g. F is x squared plus 1. Now, g, what is its job? G always takes the input, no matter what you give it, and subtracts 1. So, whatever we give it, and this time we're giving it x squared plus 1, it's going to take that input and subtract 1. So when the input is x squared plus 1, and you subtract 1, I'm getting just x squared for g composed with f. And like I say, for the first, this is my first answer, the expression, I wasn't expecting the same answer that I have over here. Now my second answer over here was the domain is all real numbers for this function composition. Well, that's what I'm going to get for this function composition as well. Two things have to be true to be in the domain of golf. First, your input x has to be in the domain of f. Well, you have that covered because the domain of f is all real numbers. You can't find a number that's not in the domain. Any number that you pick from the real number line can be an input into this function, and it's guaranteed that you'll have an output because this thing only squares it and adds 1. Now, into my next function, what has to be true is that f of x has to be in the domain of g. But the domain of g is all real numbers. So hey, anything f wants anything that comes out of function f, g is going to accept. G accepts any real number, and what it produces, well, whatever is in the input is in between parentheses. This time we're inputting f of x. So g of f of x, the domain for golf. No restrictions, no problems through f. No restrictions, no problems through g, is all real numbers. So my two answers for B, the expression was x squared, and the domain for golf is all real numbers. Let's take a look here. Oh, I didn't say what we wanted. F composed with f. All right. So we're taking the function f and we're plugging it into itself. So we're not even using g for this part. F of x is x squared plus 1. That's my input. What does f do to the input? Well, f always creates an addition problem. It always takes the input and squares it and then adds 1. This time the input is this quadratic. It is going to square this and add 1. Remember, exponents don't distribute. This is x squared plus 1 times x squared plus 1, which is x to the 4th plus 2x squared plus 1, and then plus another 1 is plus 2. So f composed with f is this expression, x raised to the 4th power plus 2x squared plus 2. Now, when you're figuring out the composition, x has to be in the domain of f to get an output. X has to be in the domain of f. Well, it's definitely in the domain of f because the domain of f is all real numbers. This f of x now goes into, well, another f. This f is duplicated. So what comes out is f of x, provided that f of x is in the domain of f. Since the domain of f is all real numbers, guaranteed that this f of x that came out of the function is a real number, so it can go into itself again. And the domain of f composed with f has no restrictions. Any number you want to plug in, whatever comes out, hey, any number you want to plug in. So now the numbers that we plug in, if you think about it, they could be negative. It can be any real number. But once you square it and then add 1, I guarantee that this f of x is always going to be a positive number. It's never going to be negative, but that's okay, because it's just going to square it again and add 1. You know, I don't think you can be more positive, but it is an increase. It is a larger value. So there's my answers for problem 1. Let's stop and I'll do these problems one at a time. So I hope that helps.